All right, 11.1 is infinite sequences and summation notation. 11.1, well, sequences and summation notation. So in this chapter, we're going to spend time on sequences in 11.1, 11.2, and 11.3. 11.1 is just generally sequences. In 11.2, it's arithmetic sequences, and then 11.3 is geometric sequences. The problem with 11.1, we cover pretty much all sequences, and then in 11.2 we focus on a second type. So I'd make the argument 11.1 is more difficult than the other two because it's just all sequences, and then when we only talk about arithmetic sequences, there's like formulas, and they're all kind of the same. Same with geometric. There's formulas to find things, but sequences in general, well, we're kind of talking about everything. An infinite sequence goes on forever. So if I don't know, if I double something, if I have an amount, let's say I have 3 rulers, and I'm doubling it every time. I've got 3, and then I've got 6, and then I've got 12, and then I've got 24. That's going to go on forever and ever. It's not coming to an end. Okay, so if it goes on forever and ever, it goes to infinity. It's called an infinite sequence. A finite sequence means it ends. So let's just say we have 5 terms, then the 5th term would be that, and it would just be a finite sequence just because it ends. If you have, well, I'll do this example. A sub n, by the way, n in math implies that it's an integer. Most times we have x's, but x's can be decimals or it can be fractions. If you have n, it's kind of implied that you can't have a half of an n, or n can't be a half, or 0.3, something like that. If you have the notation a sub n equals 4n minus 1, we can figure out what a sub 1 is by just plugging 1 in. So it's 4 times 1 minus 3, we get 3. So this is just kind of the notation. I could find a sub 10. It'd be just 40 minus 1, so 39. All right. Find the nth term of this. 2, 5, 8, 11. 2, 5, 8, 11. Well, can you see what the pattern is? Okay, we're going up 3. So this, if we're going up 3 every single time, this is called an arithmetic sequence, like I was talking about. In 11.2, we only talk about arithmetic sequences. This is arithmetic sequence because it has a common difference. It goes up or down the same amount every time. Okay, so everyone sees that it is plus 3. You also would know that the next term would be 14, but what is the nth term? Well, we know that it's going up 3. That's our common difference, so it's going to be 3n. A sub n equals 3n. Now, how do I go from 3 to 2? How do I go from this number to that number? Well, we have to do what? Subtract 1. 3n minus 1. So 3, this whatever we're going up by, and this will be the y-intercept. So let's check. For my first term, if I plug in 1 for n, 3 times 1 is 3, minus 1 is 2. If this is my 4th term, I could plug 4 in. 3 times 4 is 12, minus 1 does give you 11. So figure out whatever you're going up or down. That's kind of your slope. And then how do you go from 3 to 2? It's subtract 1. So let's try another one. Let's try... see if you can give me the nth term for this one. Anybody? What do you think, Wild? What'd you say? 5n plus 1. Is that what we're getting? Good. So nth term would be a sub n equals 5n plus 1. I know I'm going up 5 every time. How do I go from 5 to 6? I can just add 1. And you can always check, like if I want to know the third term here, you could plug 3 in. 5 times 3 is 15, plus 1 gives me 60. Feeling pretty good about my answer. Let's try one more. Give me the nth term. All right, so we're going down 2, so it's going to be negative 2n, and then what? Plus 12, good. Let's try one that's not an arithmetic. See if you can figure this out. See if you can give me the nth term for this one. Or, yeah, the nth term. Okay, so a number you probably saw that it went up 3, up 5, up 7, so you could figure out that the next term is going to be what? What do you say?
25.
25. Good. Is that what he said?
Yeah, I said just go up 9.
Oh, up 9. Oh, sorry. So 25 would be the next term, and then the next one after that would be 36. But that's not the nth term. Anybody know what the nth term is on this?
N squared.
Very good. It's n squared. A sub n equals n squared. 1 squared, 2 squared, 3 squared, 4 squared, and so on. Raise your hand if you have that. All right. A few of you. So that's just another way. That's an nth term that's not an arithmetic. If you have something that relies on previous term or terms, it's something called recursive. So it uses previous terms to find the next term. So the most common sequence, probably of any sequence, is something called the Fibonacci sequence. So the Fibonacci sequence has a lot of different applications, like the cornucopia. Oh boy, why am I even trying to draw that? Okay, that is not a cornucopia. Do you know what a cornucopia is?
Yeah.
Other than a town in Wisconsin? So I think there's some applications for Fibonacci for there. So Fibonacci is 1, 1, 2, 3, 5, 8, 13. What's my next term? 21. And how did you get that? Good. 21, you add the previous two numbers. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5. This is going to be 21. If I want the next one, it would be 35, and so on. This is recursively defined because it depends on the previous term. So to find the current term, you would take the previous term, which is a sub n minus 1, and then the one before that, which is a sub n minus 2. That's the current term. That's the previous term. That's the one before that. So if I was going to draw out, let's say I have a sub n equals 3 a sub n minus 1 plus 4. And I'm going to say a sub 1 is 2. And focus, please. So then what is a sub 2 going to be? Well, to get the current one, if a sub 2 is current, I'm just going to put 2 in for n because we're looking for a sub 2. So I'm going to put 2 right there and I'm going to put 2 right there. So that'll be a sub 2 equals 3 a sub 2 minus 1 plus 4. So a sub 2 equals 3 a sub 1 plus 4. And we know that a sub 1 is 2. So now it's 3 times 2 plus 4 gives you 10. So you can kind of think of it as, to get the current one, you just multiply the previous one times 3 and add 4. If you want to, you can put numbers in for n, and it kind of lays out the math for you, and you can substitute in what you know. So what would a sub 3 be? The third term. Don't say it. See if you can figure it out. All right. Can anybody know or guess? 34 is right. Yep. So did you just like do this times 3 plus 4? 10. So 3 times the previous one plus 4, so 3 times 10 is 30 plus 4 is 34. We could put 3 in for n right here. So you would get a sub 3 equals 3. A sub 3 minus 1 is 2 plus 4. I mean, any way you do it, 3 times the previous one plus 4, we get 34. That's called recursively defined. I'll give you another example you can try. Okay, so I wrote this a little bit differently in that this is now considered the next one. Like up here I had the current one, you have to use the previous one. This one, to find the next one, you have to use the current one. It's kind of interchangeable. It just depends on what you define x, the term to be. Is it current or next? So see if you can figure out what a sub 3 is here. All right, so to find the next one, we have to do 2 times the current one minus 1. So we have to first find out what a sub 2 is. So 2 times the current one, so 2 times 5, so 10 minus 1, we get 9, right? And then to find out what a sub 3 is, we take the 2 times the current one. So 2 times 9 is 18, minus 1, we get 17. 30. Make sense? Okay, so that's called recursively defined. It explicitly defined is when we find the nth term. Recursively defined, it'll have a sub n's in them. Explicitly defined. It's a little bit confusing. All right, so moving on, we've got factorials. You've done factorials before. I feel like we might have done it like the first week of class, maybe even like math bingo, we were doing factorial. So if you have n factorial, it's just everything multiplied all the way down to 1, which is 24. 0 factorial sounds like it should be 0. It's actually 1 the way it's defined. So 0 factorial is 1. If I was going to simplify, say 8 factorial over 5 factorial, what would that be? Well, you should be able to do this without a calculator. Okay, so 8 factorial is a big old number. Five factorial is 5 times 4 times 3 times 2 times 1. And we can see that all of these divide off to be just 1. So 8 factorial over 5 factorial doesn't mean it's easy without a calculator. 8 times 7, 56 times 6, 336. Okay? Why don't you try this one?
Can I interview Ben Mo? 2 seconds.
All right, see if you can simplify that. Make sense? That was a quick interview.
Yeah, little on both sides.
All right. How about, what if I had n plus 1 factorial over n factorial? See if we can simplify that. I'll give you a second to think about it. This is a little bit trickier, and then I'll kind of go through it. All right, so what does n plus 1 factorial? Well, it starts by multiplying n plus 1 times one number less than that. What's 1 less than n plus 1? N. Very good. And then times 1 less than that. What's 1 less than 1? Or 1 less than n? N minus 1, n minus 2, n minus 3, all the way down to 1 eventually. Well, what does n factorial look like? Well, it starts with n, and then 1 less than that, which is n minus 1, and n minus 2, and all the way down to 1 also. So they're basically the same thing, except the top one has one more factor. So it's just going to be n plus 1. That's what that simplifies to be. Make sense? This sort of thing, just sequences in general, you will not see this stuff in Calc AB or Calc 1. It's a lot of this comes up, well, all of this will come up in Calc BC or Calc 2. So if you're continuing the sequence of math classes, this stuff will not be around for next year. It'll be the year after that, just so you know. But it's a lot of we do a lot of this stuff in Calc BC or Calc 2. All right, summation notation. If I have let's just say 3i plus 4 to 5. So if I was going to add this right here is called summation notation. It's also called sigma notation. It always means sum. So we are adding up a whole, well, a number of different terms. We start with this one when I is 1, and we go all the way until it gets to 5. So the first term would be 3 times 1 plus 4, and then the next term we go up by 1, so it would be 3 times 2 plus 4. 3 times 3 plus 4, 3 times 4 plus 4, and 3 times 5 plus 4. Okay, we have 7 plus 10, 13, 16, and 19. Add all those up, 17, 30, 46, 56, 65, something like that. So I get 65. So the answer is 65. This is asking you to add up all the terms going from 1 to 5. Well, it's tempting to just say there's 4 terms because you go from 1 to 5. To go from 1 to 5, you go up 4 times, but it's actually going to be one more than that. It's this number minus this number plus 1, because we start from 1, 2, 3, 4, 5. There's 5 different terms. That's summation notation. A series is the summation of the terms of the sequence. That's we just did a series from 1 to 5. An alternating sequence is one in which the signs will go to the 10, 8, 6, 4, 1. It goes from 10 to negative 8 to positive 6 to negative 4. That's just called an alternating sequence. Lots of applications later on in math class. Questions?